6 years ago, this empty field was used for turfgrass production. Once it was discovered that any chemicals used here would leach into the groundwater, it was taken out of cultivation and left for weeds to take over. Now it's a wasteland of invasive mugwort and woody shrubs. But we're looking to change that. We're planning on removing the invasive plants and replacing them with native species that will support a diverse community of grassland birds and pollinator species. Join us as we use restoration ecology to make the world a better place, one forgotten field at a time. The first thing we had to do was document what was already at the site. The best way to handle a species invasion is to know your enemy. So does it reproduce by seed alone, or do we have to worry about it growing back from the roots as well? Some invasive plants are also allelopathic, which means that they change the soil in ways that makes it difficult for native species to grow there. So we had to survey the site, see what we were up against, and then do research to find out the best way to approach the problem. We found a lot of mugwort at the site, which is a real beast to get rid of. Usually land managers enlist herbicides to help them out, but because our site was within a wellhead protection area, we weren't able to do that. We had to get a little bit more creative. We also found a lot of woody shrubs and young trees that had to be removed if we wanted to maintain the area as grassland habitat. But most importantly, we also found desirable species like milkweeds that we wanted to keep at the site and hopefully see spread over time. In addition to conducting a baseline site visit, we also investigated the prior and current land uses at the site.
When investigating the prior land uses of our restoration site, we examined historic aerial photography provided from the Rhode Island Geographic Information System database and anecdotal accounts from the current land manager, Tim Sherman. It appears that this proposed restoration site had been an open turfgrass science experimentation field broken into a variety of plots since at least 1939. A maintained gravel road can be seen in the earliest photos, dividing the property towards 30-acre pond. Today, the area targeted for restoration is still owned by URI, but does not currently serve any research purposes and is unmanaged outside of some seasonal mowing. It is publicly accessible, part of the Gardner Crops Research Center, also known as the URI Agronomy Farm, and contains a well water testing site, which is in a fenced-in area consisting of approximately 1,600 square feet of space.
Next up is Josh, our expert on controlled burns, explaining the process for our preferred invasive species control method.
Prescribed burns are typically for the removal of plant-type invasive species. Before choosing to do a controlled burn, you must determine what type of plant species it is, a sprouter or a non-sprouter in simple terms. This is highly important as non-resprouter species are very effectively removed from the environment through burning and mowing, while resprouter species can reappear in the environment very quickly if not taken care of. The next thing to consider is the season. Experts usually recommend burnings be done in the winter or fall, in areas where it may be snowy, like in New England. It is limited to mostly the fall, as it is hard to come across a day in the winter where a burn is effective. Additionally, you must determine the fire return interval, or the period at which you return to do the prescribed burning once again. The process is as such: planning, prepping, burning, and cleaning up. The plan part consists of mapping out the exact area which the burn will occur and making sure that everyone involved understands it. Prepping is removing all hazards from the area and making sure the fire will keep away from any buildings or homes that may be nearby. The burning step may require authorization from your city and or state, and it's just the part where you begin the burn. And the cleaning up is making sure that you take out any fires that may be going outside of the containment zone, and it also extends all the way through until the end, where at the end you make sure that there's nothing left burning so that nothing could extend elsewhere while you're gone.
We were unable to do a controlled burn at our site, so we tried to manually remove the invasive weeds instead.
Manual removal, or hand pulling, can be an effective management practice, as it is often the quickest and easiest way to halt invaders when first spotted. From the literature, we learn that it is generally favored when combating small infestations of invasive plant species and is best suited for smaller plants with a shallow root system that are growing in loose soil. Hand pulling is also a beneficial strategy when leveraging large numbers of unskilled volunteers, as it does not require extensive training beyond the successful identification of a target species for removal. However, when a large set of volunteers is not available, manual removal can be expensive and time-consuming. In addition to these deterrents, roots that break off during extraction will sometimes resprout, and the removal process can cause unwanted soil disturbance, which can result in favorable conditions for new plants to invade. After implementing this strategy for an afternoon session, it was deemed ineffective for a number of reasons. Because of the size, soil structure, and degree of infestation at our site, the manual removal of species like common mugwort and multiflora rose, which heavily invade certain areas of the field, was just not practical. However, the use of hand tools, like a handsaw or chainsaw, are still preferred for removal of large woody shrubs which cannot be mowed. Early spring, before native species have emerged, and fall, when the soil is still manageable enough for disturbances, are the best times of year to perform this process. It should be noted that manual removal typically requires multiple visits over the season to prevent reestablishment.
After the initial site preparation, we planned to seed desirable native species. Here is group member Jared with information on seeding.
As far as seeding is concerned, we selected species that we predicted would perform well in our site and our local environment while having positive impacts for pollinators and for migratory birds. We looked at other grass and restoration projects in New England as well as what native species were already growing in nearby sites. We collected some seeds from the wild and from our restoration site before mowing and compiled a list of several seed vendors in Rhode Island which could supply the rest of our seed mixes, a few being Chase Farms, Rhodey Native, Blue Moon Farm, and Central Nurseries. This list is compiled from the Rhode Island Natural History Survey, and we just wanted to get a mix of local and distant seeds to increase the diversity of the seed mix and the likelihood that we will get genotypes that would work better at our site. Some of the species we've selected for our site would be sedge grasses, such as fringed, northern long, greater bladder, swallow, and tussock, and then other manna grasses like rattlesnake, Atlantic, and fowl, followed by aster, goldenrod, and milkweed species. And then along with these species, several other berry-producing species could be interplanted along the perimeter of the mowing paths, such as huckleberry, blueberry, arrowwood, chokeberry, and serviceberry. These species are all native and flower throughout the growing season to provide for the pollinators. The berry-producing plants are rich in antioxidants and nutrients which will be available in the fall for the birds as they migrate south. Storing and preparing the collected seeds is also an important part to making sure they are viable and will germinate after planting them. The majority of the seeds will be bought and stored with dry without any major complications. The milkweed seeds would have to be prepared by removing the silk around the seed pod, which is commonly done by flash burning them. When actually planting our seeds in the late winter and early spring, we figured we would try different methods to research the most effective way of germinating the seeds. One method would be the seed drill, which would give the most soil contact for the seeds and would likely give the best survival rates, but requires more labor. Another method would be seeding directly after mowing. This would reduce the competition, but wouldn't have as much contact with the soil, so would likely incur lower survival rates. And then lastly, we could overseed in specific areas to guarantee that the seeds establish in that site. Our site would be split into many smaller plots for mixed diversities and to promote natural dispersal. We would use lessons from Stephen Hendel and Karen Kettenring to create 2 different seed mixes of higher and lower diversities and spread them throughout the site. This will hopefully promote the establishment of our mixes and aid in future dispersal.
Now I am going to demonstrate how to clean milkweed seeds by burning to prepare them for planting.
Hello?
Are you filming me?
Mm-hmm.
Alright. So this is a milkweed pod. I collected them from a roadside close to our restoration site. And the way that you clean all the silk off of the seeds is by burning them. So just take them out of the pod and put them in, I don't know, some fireproof container, and then light it on fire.
In addition to seeding, our restoration site will require repeated mowing to manage for invasive species. Liam is going to tell us more.
The decision to mow our site required the consideration of wildlife and soil in order to avoid disturbance. Because of this, I looked into the nesting times of songbirds and turtle species that may use the site in the future. Songbirds typically have a nesting period between mid-May and mid-August, while turtles emerge and begin nesting sometime in the spring and usually hatch by the end of the summer. Therefore, we decided that mowing should occur sometime after September, but before April. Because of this, mowing will also take place during dry or frozen ground conditions, as this will minimize any negative impacts to the soil. For future control, to prevent the return of woody and non-native species, we'll likely use a rotary or sickle bar mower adjusted above the height of the grass culms, no more than 9 inches. This will preserve native grasses we're trying to have grow back. We'll also exhaust the seed bank while preventing woody encroachment. No more than 1/3 of the returned grassland will be mowed during a year. This will preserve habitat availability and heterogeneity in the grassland structure.
The folks involved with maintaining the site, as well as those who closely monitor it for species diversity, would like to transform the area from its current overgrown state into a grassland habitat. After restoring the property to a grassland habitat, those involved with maintaining the site would like to use the property as an educational tool for future university classes. Not only would this area potentially highlight the benefits of ecological restoration, it could also be used to showcase the local species diversity for classes that focus on wildlife and botany. This change would require some construction, including a potential walking trail, additional wooden fencing, and some signage to describe the restoration process. This application, though, would increase the recreational and social benefits of the property, which may help engage the community in maintaining the upkeep for generations to come.
This fall is only the beginning of a long restoration process. Hopefully, our native seeds will get a head start in the spring, but those invasive plants are going to come back. And without herbicides, it's going to be difficult to fight back. But with constant pressure from mowing, hand-pulling, and reseeding native species, we'll eventually turn the tide. We'll have a native grassland area. This place will showcase how restoration ecology is done, highlight the importance of teamwork, and proves that a small number of people can make a difference, one forgotten field at a time.